Okay, this next quick lesson comes with some exercises, so there's some math practice for you guys to do. How do we add up the capacitance in a circuit if we have multiple capacitors connected together in series? Okay, well, we'll start the conversation in the same place we usually do, which is let's figure out what happens with a resistor and then translate that information to a different type of load. So if we have multiple resistors connected in series, how do we calculate the total resistance? Okay, so RT equals, when connected in series, just add them up, right? R1 plus R2 and so on. So how should we add up the capacitive reactance? Because reactance is the equivalent to resistance. Okay, it's different but the same. It's still an ohmic value. So the total capacitive reactance in this circuit, how would we add this up? We do exactly that. Just add it up. So it's XC1 plus XC2 and so on, however many capacitors we have connected together. Now the tricky part, how do we calculate the total capacitance of the circuit? So remember the equation, capacitive reactance is the inverse of 2 pi FC. So we have an inversely proportional relationship between capacitance and capacitive reactance. So if we add up multiple capacitive reactances to get a larger number, we expect to find the exact opposite happening, the inverse effect, when adding up the total capacitance. Okay, so this equation is also a familiar one. Okay, it's exactly the same equation that we use to calculate total resistance when the resistors are connected in parallel. So it's the inverse of the total capacitance will be equal to the inverse of the size of the first capacitor plus the inverse of the size of the second capacitor. Now, it starts to get messy, and we can do this one more time, move the inverse over, so it's CT equals the inverse of, okay, our standard reciprocal equation that we use to calculate resistance in a parallel circuit. But let's think about this for a second. So if we were to consider this as a single capacitor rather than a couple of capacitors connected in series, remember the variables that are used to calculate the capacitance, and this is going way back into your memory banks, but a couple of variables were the size of the plates, the two plates of our capacitor, and the type of the dielectric. Well, if you look at this, when we place two capacitors in series, effectively, we now have only those two plates, and everything in between is the dielectric. So we've got a dielectric here and a dielectric there, a couple more plates and some wire in between. Okay, but we've really affected what it is that's between the two plates of our capacitor, if we think about this as a single capacitor. Okay, which reduces the ability for the capacitor to be a capacitor, is effectively what happens. So every time we add an additional capacitor in series, okay, we're reducing the capacitance of the circuit. Okay, so if that's too much to think about, just go back to the fact that a capacitor is the exact opposite. Okay, and connecting resistors in series means add them all up, but connecting capacitors in series, when talking about the capacitance, we're using the inverse equation. But if we're just sticking to the ohmic values, the reactance compared to the resistance and reactance, ultimately they're the same thing, and so the equations are exactly the same.